You see this type of rehabilitative work more and more on our highways. The construction of concrete pavement overlays on both concrete and asphalt pavements. These overlays have great potential because they increase a pavement's structural capacity as well as correct surface deficiencies. The result is extended service life. In the past, constructing concrete overlays disrupted the normal traffic flow. Roads had to be closed. Detours had to be set up. Well, you probably remember. But recent developments in concrete technology, such as fast-track mixes and zero-clearance pavers, make it possible to construct concrete overlays with much less disruption to traffic than before. Now a concrete overlay can be placed on one lane while maintaining traffic on adjacent traffic lanes. And the pavement can be open to traffic in 12 to 24 hours. This video presentation examines the steps in constructing concrete overlays. We'll begin with some general information. Then we'll look at design considerations, pre-overlay repairs, surface preparation, concrete placement and curing, and joint sawing and sealing. An accompanying user's guide provides guidelines and guide specifications on overlay design and construction. So let's get started. General information. There are two types of concrete overlays, bonded and unbonded. Bonded overlays are joined to the existing pavement so that the two function monolithically. Unbonded overlays are separated from the existing pavement by placing a separation layer between them. The condition of the existing pavement determines which type of overlay is appropriate for a given project. Bonded overlays should be used for concrete pavements in fair to good condition but lacking structural capacity. This is a relatively new technology that is gaining popularity. Unbonded overlays are best for extensively deteriorated concrete pavements or bituminous pavements. The thickness of either type of overlay must be carefully designed by evaluating the existing pavement in detail to determine the extent of deterioration and its remaining structural capacity. AASHTO and PCA design guides provide the procedures for pavement evaluation and overlay thickness design. With that in mind, let's take a close look at the procedures involved for bonded overlays, beginning with design considerations. As I said earlier, a bonded overlay increases the pavement's structural capacity, so it's particularly useful when truck traffic increases beyond the expected level. But it also corrects surface problems such as severe roughness or low skid resistance. Bonding a relatively thin layer of concrete to an existing concrete pavement can greatly reduce the critical stresses in the slab. So one of the keys to improving structural capacity is to provide a good bond between the overlay and the base concrete. That way the two will act monolithically. Equally important is the condition of the original pavement, because it remains an integral part of the pavement structure after overlaying. For example, pavements with significant deterioration due to durability problems such as decracking or reactive aggregate are not good candidates for bonded concrete overlays. For the overlay to perform well, all distresses in the base pavement that would reflect through the overlay or impede bonding have to be corrected. And that brings us to pre-overlay repairs. The purpose here is to correct the problems of faulted joints, pumping and loss of support, working cracks, shattered slabs, deteriorated joints, and unsealed joints. Loss of support can be identified by signs of pumping and verified by deflection testing. Substantial loss of support has to be corrected by stabilizing the slab. Major faulting along joints can also be caused by loss of support. Here again, slab stabilization can be used, but only after making a sub-drainage evaluation and improving drainage if required. These two repair methods, when called for, should precede all other repair operations. Transverse cracks may be repaired by retrofitting dowel or tie bars across them. Then in the overlay, the retrofitted crack must be sawed and treated as a joint. Working longitudinal cracks can be cross-stitched. This involves drilling holes at an angle through the crack and grouting in deformed tie bars. Cross-stitching will hold the crack together, but it will not necessarily prevent the crack from reflecting through the overlay. Seriously deteriorated joints, those exhibiting corner breaks, deep spalling, or blow-ups, should be full-depth repaired. Shallow spalls, on the other hand, can be either sawed or milled partial depth to sound concrete. The excavated areas can then be filled during paving operations. But if their depth exceeds 2 inches, they should be filled and cured prior to paving. Unsealed joints must be sealed prior to surface preparation to keep the bonding agent, overlay concrete, and other incompressibles from filling the joints during cleaning and paving operations. Now we're ready for surface preparation. The pavement must be thoroughly cleaned to remove all foreign matter and contaminants from the surface. Cleaning is essential for a good bond between the overlay concrete and the base slab. This can be achieved by removing a thin layer of concrete at the surface and then following up with a secondary cleaning. Shot blasting and cold milling are effective methods of surface removal. Shot blasting equipment hurls steel shot at the pavement under a housing unit to remove about 1/8 inch of the surface. The shot is recycled and the removed concrete is vacuumed, leaving the surface free of loose material and dust. The process leaves a rough, highly porous surface that helps develop a strong bond. Although shot blasting leaves the surface ready for overlaying, secondary cleaning is recommended just ahead of the overlay placement. Cold milling is used when deep removal is required. This procedure can remove up to 1 inch of the old concrete, leaving a very rough surface that helps bonding. In some cases, though, milling may cause some micro-cracking at the surface and spalling at the joints. A secondary cleaning is required when cold milling is used. Secondary cleaning removes all dust and loose material from the pavement surface ahead of the overlaying. Either sandblasting or water blasting can be used. Sandblasting removes an additional 1/32 inch to 1/16 inch from the surface. While it occasionally has been used for primary surface preparation, sandblasting does not adequately remove all contaminants from the surface. It's therefore recommended only for secondary cleaning. Water blasting can be effective for secondary cleaning too, but it requires extra time to allow the prepared surface to dry before paving can begin. Whichever method is used, the prepared surface should then be air blasted to ensure that it's completely free of dust and debris. The air blasting should be done just before the overlaying to prevent contaminants from resettling on the surface. Now for concrete placement and curing. A common practice is to apply a bonding material to the prepared surface immediately before placing the concrete overlay. The proposed bonding procedure and material should be tested beforehand under conditions as close as possible to those in the field to ensure that good bond will develop. As a bonding material, a neat cement grout that consists only of cement and water provides good bond strength. The water-to-cement ratio should not exceed 6/10. The grout should be stir-agitated throughout the duration of application. A mechanical spraying device is typically used to apply the grout a short distance ahead of the paver. To ensure an even coating, the grout can then be spread with either a stiff brush or broom. There should be no running or puddling. The bonding application should stay close to the paving operation to keep the grout from drying. Dried grout is detrimental to bonding. A maximum distance of 8 feet between spraying and paving is recommended. If the grout does dry out, the paving operation must be stopped and the dried grout must be thoroughly removed by either shot blasting or sandblasting. Sand, cement, water grout, and epoxy have also been used successfully as bonding materials, although the use of epoxy is still relatively new. Since epoxy materials have a moderate working life in hot environments, they may help solve the construction problems associated with early grout drying. Concrete placement is substantially the same for bonded concrete overlays as it is for new construction. However, trucks that must be operated on the clean surface should be fitted with diapers to catch any dripping oil or grease. As with any concrete, curing is critical. In normal weather conditions, good results have been obtained with a curing compound applied at 1.5 to 2 times the normal rate. Under extremely hot, dry, and windy conditions, more effective curing measures are required. These include wet burlap, polyethylene sheeting, and surface fogging. However, the placement of bonded concrete overlays is not recommended during extremely hot or rapidly changing weather. If a large temperature drop is expected from day to night, the use of fast-track mixes should be considered. Otherwise, the extreme cooling before the concrete has gained enough strength to resist thermal stresses can cause cracking and debonding, particularly at slab corners. Fast-track mixes should develop enough strength to resist the thermal stresses before the temperature drops. Another possible solution is the use of insulation blankets. And that brings us to the last steps: joint sawing and sealing. As with any concrete paving, the joints have to be sawed as soon as possible. The saw cuts have to be made directly over the joints in the base slab. If the overlay thickness is 4 inches or less, the joint should be sawed to the full depth of the overlay, plus an additional 1/2 inch into the base slab to ensure that the full thickness is cut. For thicker overlays, the recommended depth of sawing is 1/3 the nominal thickness of the overlay, or a minimum depth of 3 inches. Any expansion joints in the existing pavement should be specially marked and reproduced in width on the overlay. After sawing, the joints should be sealed using conventional methods and materials. And those are the procedures for constructing bonded concrete overlays. Remember, these are most effective when the pavement is in fair to good condition, so it's very important to determine future needs when considering bonded overlays. Now let's look at unbonded concrete overlays. These have been used successfully to rehabilitate extensively deteriorated concrete pavements and bituminous pavements. In contrast to bonded overlay construction, where achieving bond between the overlay and the base concrete is a major concern, an unbonded overlay separates the two pavement layers to prevent reflection cracks. This is accomplished by placing a separation layer between the overlay and the base pavement. This isolates the overlay from the movements of the underlying pavement, reducing the likelihood of reflection cracking. This also eliminates the need for extensive pre-overlay repair. Minimal pre-overlay repair is the principal advantage of unbonded concrete overlays. Only serious distresses in advanced stages need to be repaired before an unbonded concrete overlay is placed. For example, high-severity spalls at joints should be filled and compacted with bituminous patching mix. Shattered slabs that are rocking should be replaced. Faulting greater than 1/4 inch may need to be removed when a thin separation material is used. Faulting is not a problem, though, when a thick separation layer is used, such as 1 inch to 1.5 inches of asphalt concrete. On bituminous pavements, severe surface distortion should be milled off or leveled by placing a leveling course. Potholes should be filled, and areas of badly failed base should be removed and replaced. In lieu of pre-overlay repairs, cracking and seeding or rubbleizing may be used on concrete pavements to provide uniform support for the overlay. On severely deteriorated pavements with major structural problems, these techniques may be more effective than pre-overlay repairs. Although unbonded overlays do not require extensive pre-overlay repairs, the repairs that are made influence the required overlay thickness and performance. The amount of repair must be carefully weighed against overlay thickness and expected service life to arrive at an economic design. Beyond pre-overlay repairs, the surface preparation includes filling all joints and removing loose material from the pavement surface. Filling joints will help prevent moisture from penetrating the subbase. Liquid asphalt sealants are recommended for this application. The placement of the separation layer can be considered to be the final surface preparation. Several types of materials have been used, but polyethylene sheeting, roofing paper, and curing compound have not performed well. Best results have been obtained using hot mix asphalt concrete. A layer of hot mix, 1 to 1.5 inches thick, can effectively isolate the overlay from the base slab and also serve as a leveling course to smooth undulations and surface roughness for the paving operation. This is the recommended separation layer material for unbonded concrete overlays. Bituminous slurry seals have also been used effectively as bond breakers. During hot summer days, if asphalt concrete is being used as a separation layer, whitewash may have to be applied to prevent excessive heat buildup. Otherwise, shrinkage cracking may occur in the concrete overlay. The whitewash consists of either white pigmented curing compound or lime slurry. It can reduce surface temperature by 20 to 30 degrees Fahrenheit. Now, concrete placement and curing. No special techniques are involved in the construction of unbonded concrete overlays. Conventional concrete paving procedures should be used, and reinforcement or dowels should be provided for as required. Immediately after the surface has been textured, curing compound should be applied at the normal rate. Then, joint sawing and sealing. As in new construction, the joints on the overlay should be sawed as soon as the concrete has cured enough not to ravel during sawing. Unbonded concrete overlays on jointed, plain concrete pavements require shorter joint spacing than other concrete pavements do. The thermal gradient, friction with the separation layer, and very stiff support provided by the underlying slabs all help create greater curling stresses in the overlays. Either shorter joint spacing should be used or reinforcement should be provided to control any cracks that may develop. For example, joints should be placed every 7 feet on a 4-inch overlay. The joints in unbonded concrete overlays should be sealed using the same procedure and materials used for new pavements. The construction of either a bonded or unbonded overlay requires new shoulders. Either a bituminous or tied concrete shoulder can be constructed. A tied concrete shoulder can be placed integrally with the overlay. Tied concrete shoulders are effective in reducing critical edge stresses and deflections in the mainline pavement. And that brings us to the end of this program covering concrete pavement overlays. For further information, you should consult the Sharp C206 User's Guide for Rehabilitation of Highway Concrete. It provides guidelines and guide specifications on their design and construction.